Hi everybody, and welcome to the adding and subtracting rational expressions video. In this video, our first our first objective is going to be given two rational expressions with a common denominator. What we're going to end up doing is just adding the numerators together, factoring, and reducing. So again, we're still on this whole factor and reduce our final answer when we're done. And then our second objective would be to find the least common denominator or the lowest common denominator, which we will use in the next video on section 7.4, which would be adding and subtracting rational expressions with uncommon denominators. So in this video, we'll focus with common, and the next video we'll focus when we actually have to find it. So in this video, the second objective, again, we will take a look at finding the lowest or the least common denominator, whichever it is you're used to calling this thing. So let's take a look now at adding two rational expressions. So we have 13m over 4n, and we would like to add 11m over 4n. So just like with numerical fractions, so say, I don't know, 4/3 plus 2/3. So notice that in order to add fractions together, as you already know, whether you've been out of school for a long period of time, you still have these nightmares of coming up with the common denominator. So we'll welcome you back to your nightmare days. So again, when we have our common denominator, in this case is 3, we just add the tops, and notice here we get a 6. And once we do the addition, our next step would be to reduce. And again, with rational expressions, we found out that reduce means to factor and then put on our Freddy Krueger and start slashing. So here we just end up with 2. All right, so since we already have the common denominator, let's just note that we can write this, go ahead and just write this over the common denominator, 4 over n, and then notice that this is 13m plus 11n. All right, so we just add the top, so we get 24n over, m, maybe it's right, we should stick with x and y's, m's over 4n. And again, we have to reduce. So one of the things we can observe is that 4 goes into 24, and we're left with a 6. So our final answer is 6m over n. And here we've got our final answer. Okay. So let's just move right along, and here we get 5y over y minus 8 minus 40 over y minus 8. So again, we've already got our common denominator, so let's just go ahead and write that down and get her out of the way. All right, and notice that the top becomes 5y minus 40. Okay, so now that we have that completed, there's no like terms to collect. So we can go ahead and take a look at this top part, and let's just observe that we can factor a 5. So we're left with y minus 8 divided by y minus 8. And again here we can go ahead and cancel. So this subtraction reduces all the way down to 5. So for our next example, let's take a look at 7 over 15 plus x plus x plus 3 over 15 plus x. Okay, so again, we already have our like denominators here, so I'll just come over here and write 15 plus x, and notice up top we could just go ahead and add the tops together like this. So here we have some like terms, so the 7 and 3 combined, so we get x plus 10 divided by x plus 15. Now notice there's nothing to factor in the top. There's nothing to factor in the bottom. And again, please note, do not do this. That's a no-no. And do not try to say that this is a 2 and this is a 5. All right, we cannot do that. Our final answer is x plus 10 divided by x plus 15. Okay, that is it. This red is a no-no. Okay. All right, let's kick it up a notch. Just a couple more here. Let's take a look at x over x squared minus 2x minus 48 minus 8 over x squared minus 2x minus 48. All right, so again, notice that we have our common denominator of x squared minus 2x minus 48. And then up top, we just go ahead and do our x minus 8. All right, so notice that we are not done yet. So notice that the top does not factor. So I can go ahead and just write the top down here. And let's notice that since the leading coefficient here is a 1, we can go ahead again and write our two brackets down and go x and x. So then the question is, what is the factors of negative 48 that add up to negative 2? And I came up with minus 8 and plus 6, so let's just verify. So negative 8 times 6 is our negative 48, so that checks. And notice that our negative 8 plus 6 is our negative 2, so that checks. So let's just observe that the x minus 8s cancel out, so I'm left with a 1 up top. And let's notice that we have x plus 6 on the bottom. So that is our final answer, and we do not need to use a lifeline. So that's our first objective, and that is adding and subtracting rational expressions when we already have common denominators. So our second objective is to find the LCD between two rational statements. All right, so to find the LCD, I guess there's many ways of doing this. There's probably the way that you read according to your author, and there's going to be the way that I'm going to take a look at how I do it. Okay, and what I do when I do these, so here I have 2. Notice that there's no plus or minus. Notice we have our little comma. So our comma is just asking us, so the instructions would be find the LCD for each pair. All right, so this is going to be our working instruction for the next, let's see what I got, 1, 2, 3, about 5 examples. So find, like it's lost, find the LCD for each pair. Okay, assuming the pair is the rational expressions. All right, so since we're only after the LCD, let's just note that all we have to do is we're going to only work with the denominators. So I'm going to come over here, do a little side work here, and let's just note that we have the denominator for the first set and the denominator for the second set. All right, so the idea is, at the end of the day, what we're going to want is for these things to look the same. That's our goal. How do I get these two monomials to look exactly the same? And that's it. That's the game. Get them to look exactly the same. So I believe on page 466 in that purple box, they have a step 1 and step 2. So we're going to kind of play this little look-alike game is basically what it looks like. So starting off, let's just observe that when we take a look at the number, the question then becomes, what do I have to do, if anything, to the numbers to get the numbers to look the same? So I'm hoping that you will agree that if I take a look at the left-hand side with the 5 and the right-hand side with the 15, can we agree that 15 is going to be what we're going to go after? And in order for the left side to look like a 15, that we have to multiply the left side by a 3. All right, so once we have that number done, we're all done. So now let's just come over here and take a look at the variable y. So the question is, I have on the left a y to the 7th, and on the right I have just a plain old y. So now the question is, when I took a look at y and y to the 7th, then how do I get these y's to look the same? So the idea is on the right hand side, to get the y to look like a y to the 7th, I'm hoping you can agree that we have to multiply the right hand set by y to the 6th. So that takes care of the number, that takes care of the variable. Now that each is taken care of, notice if I take the right hand side and just kind of multiply straight down, if you will, notice I get 15 y to the 7th. And if I come over here to the right hand side and just kind of multiply straight down, or if it helps you out, then just write 15 times y to the 6th is really what we're doing. And at the end of the day, we get 15 y to the 7th. So hopefully we can agree that not the LCB, but the LCD, the lowest or the least common denominator in this case, is 15 y to the 7th. All right? So that would be example number 5. How's that working? And then all we got to do now is just kind of kick them up a notch. You know, just take it gradually, kick it up a notch. So let's take a look at the set 1 over 3y, comma, 2x over 9y minus 15. So again, we're only interested in the denominators. So bring the denominators over here, 3y, and, if you will, 9y minus 15. So notice that, again, here we have to employ our factoring. Let's just note that up here, we just had a number and a variable. All right, nothing to really do. If it helps you to think of factoring, then there's nothing to factor to the 5, and the 15 becomes 5 times 3 times y. And again, all you got to do is ask what's missing on each side. So we got the 5 and the 5. The 3 is missing here. So notice I multiply by a 3. I have my y to the 7th, and I have my y. Again, that carries off. Notice on the left-hand side, there's nothing to factor. On the right-hand side, and I'm just going to, for posterity, bring this down, 3y, and notice I can factor out a 3, so I get a y minus 5. So again, I'm sorry, this should be a 3 right here. Thank you for catching that. So again, we played the same game. We're just going to take a look-see now at what's missing on each thing. So notice here, I got a 3 and I got a 3. So both sides have a 3. So we're done there. So notice this side has a y. I'm not seeing a y on this side. So I'm going to put a y right here. Okay. And on the left-hand side, we're all done. There's nothing else to take a peek-see at. But notice on the right-hand side, I have this 3y minus 5, but I don't have my 3y minus 5 over here. So if I just go 3y minus 5 on this side. And again, let's just notice that if we take the whole left-hand side here, okay, and at the end of the day, we product all of this, I get 3y minus 5. And over here, I do my product again. I get 3y minus 5 times y. And notice that products, you can intermix them around. So at the end of the day, can we agree that these are the same? So that our LCD for this set is 3y minus 5. Okay? And there we have that one. All right. So let's take a look here. Let's see. I got, looks like 2 more examples, and we can call it the day. Okay, 2 more examples. So that was 6, 7. So here we get 23x minus 14 divided by 9x minus 15. And here we get 7 over 3x squared minus 12x plus 12. Okay, so again, just working with the denominators, I get 9x minus 15. And on the right-hand side, 3x squared minus 12x plus 12. All right, so do you see it? So on each side, let's just note that there's a greatest common factor in the first set on the left. So I can factor a 3. So I'm left with x minus 5. And let's notice that on this side, I got a 3. So I get x squared minus 4x plus 12 on the right-hand side. And notice still there's nothing to do, so I'm just going to write this down and bring it along. And notice on the right-hand side, the question is, can we factor this trinomial right here inside the brackets? And the answer is, I put a 12 there. Yep, that should be a 4. Okay, right here. So let's just note that this will factor to x minus 2, x minus 2. Guess I better take a look at my cheat sheet that I got over here on the side. All right, so notice everything now is completely factored. So let's just notice here, again, we got our 3 and a 3, so nothing to do. I have an x minus 5, but I'm missing an x minus 5 on this side. Okay, and notice that I have an x minus 2 and an x minus 2. Let's just note, I'm going to do a little side thing, that really this is x minus 2 squared. That's what we're going to end up with at the end of the day. So notice I'm missing an x minus 2 times x minus 2. So on this side, I just write x minus 2 squared. So again, when I do the product of these guys, I end up with 3 x minus 5 x minus 2 squared. And over here, when I do the product of these, okay, we end up with 3 x minus 2 squared times x minus 5. So again, hopefully we can see that the LCD is going to be 3 x minus 5 x minus 2 squared. Okay. And now for our last one, let's take a look at 2y divided by x minus y and 31 over y minus x. So again, these are fairly similar. So looking at the denominators, I get this set up. And again, notice that x minus y and y minus x, they're just off by they're off by the negative. So let's just notice that by our previous work, I get x minus y and I get a negative x minus y. So remember, to flip this subtraction, we just stick a negative out front and flip the negative. Technically we factored a -1. So now we can do our comparison. So notice I got the x minus y, but let's just observe I have this -1 here, so I better multiply by a -1 on this side. So notice I get negative x minus y, and I get a negative x minus y. So the LCD is negative x minus y. All right, so I hope this video helped you out, and please take some time if you need to stop, rewind, go back, take a look at some of the examples. And if there's any muddy points on here, please go ahead and bring any muddy points that you may have regarding 7.3 to the muddy point question on the warm-up. That way we can get you taken care of. And outside of that, you're ready to go check out section 7.4 video. Adios.